続きまして、Dell エンタープライズクラウドソリューションズ Powered by OpenStack OpenStack によるDellのエンタープライズクラウドソリューションと題し、シニアソリューションズアーキテクト&ビジネスディベロッパー、クラウド&ビッグデータ、Dell APJ、ピーター・ジャン様にご講演をいただきます。なお、当セッションでは同時通訳がございます。チャンネル1番で日本語をお聞きいただけます。同通レシーバーがお手元にない方はスタッフがお配りいたしますので挙手をお願いいたします。それではピーター・ジャン様、よろしくお願いいたします。
Good afternoon, everyone. My name is Peter Jung, and I'm a solutions architect and business developer, in charge of the open source cloud business and big data businesses here in APJ, based out of Sydney, Australia. Today, I'm going to talk to you about our Dell OpenStack cloud solutions. I'm going to start off with some of the challenges that, from my experiences from the customer engagement perspective, that, how the challenges that service providers and enterprises facing. Then I'm going to talk about what Dell has been doing to help customers solve those problems over the past 2 years. Also, I'm going to introduce you to Dell's cloud portfolio, which includes our recent announcement of Dell, Red Hat, OpenStack cloud solutions for enterprises powered by OpenStack. I'm going to close out my presentation with a case study which we actually helped the University of Alabama at Birmingham to architect, design, and implement OpenStack solutions in conjunction with our SAP backend cloud storage systems. This is our point of view in terms of what is going on in the industry. And I want you to have a close look at the relationships among these, these segments. Oftentimes, we heard of the many forces or trends these days. For example, cloud, big data, or social and mobile. So when we talk to the business, and the business always want you to help their business to innovate and grow. Obviously, speed time to market is absolutely required, and the business actually wants to achieve the return on investment as quickly as possible. In terms of the application requirements, unlike traditional enterprise applications, the mobile and social applications, their requirements, the back-end infrastructure should provide very agile, scale-out architecture to support those application requirements. If you look at the relationships among these forces, you have to have lots of business requirements and application requirements. And the applications generates lots of user data. And the business also wants to distill the information and insights from the data, which is business intelligence. Business also wants to piggyback the business intelligence back to their application development, thus increase their business performance. Now, the real issue for all of us here who are interested in cloud and OpenStack, indeed, is how we can help business to achieve their fundamental objectives by providing agile and quite scalable cloud architectures. So obviously, one of the biggest reasons all of us are interested in OpenStack is try to reduce total cost of ownership, TCO. So as you all are aware, this cloud infrastructure provides on-demand, self-service, automated access that actually lowers costs and decreases demands on IT. I'm going to talk to you a little bit about the challenges that service provider and enterprises facing these days. For service providers, technological choice are at the heart of their core competencies and market competitiveness because technology itself is their core business. They have to create and deliver high-quality services at very, very competitive price points in order to win the competition's marketplace and the leader market, thus sustain their business. So obviously, TCO reduction is number one reason. Number two is, I think this is more important. They actually need very flexible architecture to rapidly add and change products and features in response to customer needs. But once they adopt vendor proprietary solutions, there is quite limitations for them to be able to address market demands, which I called flexibility. As compared to service providers, the enterprise is facing different set of challenges. Obviously, enterprises adopted server virtualization or resource virtualization technologies to reduce their TCO or increase their IT efficiencies. But now, when we talk about the cloud is all about provisioning services and providing the business values to their core businesses. However, the building cloud itself is too complex and takes too long. So this is actually the enterprise's pain points we try to help them solve. What enterprise customers want from industry experts or vendors or community as a whole is they want reliable, scalable, affordable, end-to-end OpenStack solutions for enterprises. So again, when we look at the challenges that both the segments facing, it's different set of challenges. When you architect cloud, it's quite complex. We're not just talking about resource virtualization. We're not just talking about software framework. We're not just talking about business. We're talking about everything. However, architecting cloud from bottom up or top down is not an easy job. First, you need to think about all those requirements at the physical layer. That includes compute, storage, network, HVAC, power, even facility. Especially in Japan, there's a lot of requirements of the power consumption efficiencies. So power efficient data center, and on top of it, you embrace cloud technologies or solutions to enable what you want to achieve out of the whole activities. That's what you want, I believe. On top of physical layer, you also need a resource abstraction layer or relevant control layer where you can find the storage virtualization, operating systems, network virtualization, access control monitoring, or resource allocation, etc. On top of it, you want to enable those required services to help users to consume. Compute services, volume service, identity, image service, object service, or network service. These are services we call edge services. If you're interested in not just providing infrastructure service, rather you want to provide platform as a service or software as a service, you can enable those PaaS or SaaS on top of it. It's very verticalized solutions such as VDI or cloud for HPC researchers or content delivery network. So basically, depending upon the nature of the cloud or business applications, lots of various components of the stack should be very, very well assessed and selected and finely tuned for the specific requirements of the specific applications. Oftentimes, we tend to architect the cloud from bottom up. However, the other best practice is you have to architect cloud from top down, which means you have to be a bilingual to be able to understand the requirement from the business as well as requirement from your engineering departments. Again, what's very, very difficult is these all components are moving targets. On the left-hand side, you also need all those features and functions in terms of providing business support or provisioning capability or configuration management. You need a customer management, accounting, billing, auditing, inventory management system. In terms of provisioning or configuration management, you also need have a DevOps or operational software practice in place. Lastly, for a hybrid cloud, or you want to migrate your workload from public clouds into your private cloud, or the other way around, you also need to think about the capability of portability, of interoperability. Very complex, right? Let me just narrow scope down into the challenges related to deployments. Like I said earlier in these previous slides, there are many, many building blocks to architect, realize, enable cloud services, such as server, networking, storage, like resources. And a software layer, there are many projects in OpenStack as a whole, more than 1,000 parameters to configure or adjust or fine-tune. In the marketplace, there are many, many variety of tools. We can talk about Puppets or Chef or any tools available out there. By the way, this OpenStack major version, major chunks comes out every 6 months, and there are 2 or 3 minor releases in between. Basically, what you want to achieve out of these activities is to provide well-functioning cloud systems for your business, for them to utilize their business applications, thus eventually achieve their business fundamental objectives. But do you actually want all of these tools or parameters to adjust, or you just want a very nice house or mansion? The people tend to be confused. While you engineer too much and you're following so many directions, which is happening in the marketplace or community, you tend to get lost. Let's get back to our fundamental objectives. Do we want to verify, validate, or troubleshoot all those things available in the marketplace, or do you just want a very nice house and nice mansions, which is highly performing, predictable, reliable, and highly available, manageable, even scalable? Yet, there's a big gap. Let me just a little bit talk about the trends around operation. This whole cloud initiatives really require operational focus. And the operational and the process controls really, absolutely mandatory. These oftentimes operational decisions really drive hardware and software decisions as well. This diagram shows many services components or building blocks to realize OpenStack services that I talked earlier. There are API services, Nova, dashboard, all those things. But if you can't automate it, you can't scale it. You can manage or operate 10 nodes at your development lab, or 100 nodes at pre-production or small production. But what if your user demands grow so rapidly? You need to address all those demands. But at the same time, unfortunately, you don't have automation tools in place. Bottom line, if you can't automate it, you can't scale it. This Crowbar project we initiated a couple of years ago by learning and experiencing through our customer engagements. As anybody who experienced the server virtualization technologies from vendors, somehow it's easy to install, easy to manage, and easy to maintain. However, once you get your hands on OpenStack, it's a totally different game. It's all loosely decoupled messaging queue systems based. And every project has individual databases. Like I said, every 6 months, new major chunks comes out. It's a nightmare. But everybody wants to be like an Amazon Web Service. Amazon Web Service accumulated their skill set over 10 years. Then you want to bridge the gap as quickly as possible by utilizing the community of OpenStack. Yet, still you have very, very challenging operational problems. So this Crowbar project, we help customers to bring up and running the OpenStack clouds as quickly as possible with a very, very minimal intervention. From bare metal, hook up to network, and power them on. And from that time on, we want to help customers realize cloud services. So our objectives with the Crowbar project is to help customers accelerate the multi-node deployments, help them simplify maintenance, help them streamline ongoing updates. This is a big topic. Most of us here in this room heard about triple projects. I'm not sure how long it's going to take to realize the real objectives of triple projects and have every one of us to benefit from it. Yet, Crowbar, we also open source the Crowbar. And triple is obviously OpenStack's the latest project, one of the latest projects. And all these initiatives and attempts, they need to help each other, complement each other. At the end of the day, I don't mind whether it's going to be Crowbar or triple, so long as a good framework or software that can actually help us to manage updates and maintain our cloud so nicely, effectively, efficiently, I think that's the right way to do. Again, we learned all those lessons from our customer engagement and come up with a Crowbar project, which I want to introduce to you. Couple of years ago, we came on the market with first reference architecture. The reference architecture means it's not just stairway to heaven, but reference architecture really helps customers to have kind of reference as a baseline, which means oftentimes we saw customers struggling to put all those moving targets, put them together, make them working. There are many components like resources, servers, networks, or even software. what we can do, what we did, our engineering team, we actually have lots of discussions, not ourselves, the customers. They come up with the reference architecture. We config, we test drive, we validate it, we certified. And then introduce this reference architecture to customers. Hey, Mr. Customer or Mrs. Customer, this is our reference architecture, which can be maybe your reference or baseline. On top of it, you can customize or enable services that you want. It includes, on the right-hand side, is Crowbar operation platform. By the way, Crowbar is based upon the Chef. Dell density optimized servers or rack servers, switches, and a multi-cloud manager, and an ink tank self-storage systems, plus deployment guide, white papers. Deployment guides actually includes all these configuration details, plus services implementations support. The reason we come out with this reference architecture is there are so many sophisticated users as customers. Most likely they tend to know what they're doing, right? So again, this can be a reference for those customers. Yet enterprise customers' requirements be different. They want enterprise grade. They want some solutions that has risk mitigation strategies. What if my deployment, my cloud encountered bugs or critical problems? Who actually step up to communicate with the community and fix up the problems on behalf of me? It's typical enterprise-grade systems that I'm talking about. SUSE announced the SUSE Cloud 2.0 last year, and within SUSE 2 Cloud, they embrace Crowbar as an operation tool. So some of the features of this Dell SUSE Cloud solution, it also includes SUSE Studio, SUSE Manager. So again, our first initiative, which is providing reference architecture, and this enterprise-grade Dell SUSE Cloud, is two different tracks, which I'm going to talk later in my slides. Let me just a little bit talk about how we've been engaged in this OpenStack community. Since day one, we were the first hardware vendor to support this OpenStack initiative from Austin release. And obviously, Austin is the place where Dell headquartered. We learned lots of lessons to come up with a density-optimized server platform by engaging customers like the world's largest Web 2.0 companies in the West Coast of the United States. Then we believe there was the right system platform for OpenStack Cloud as well. 2011, we first publicly demoed Crowbar at Cloud Connect. The year 2012, we actually started this business in North America. Then year 2012, we expanded this one to Europe and Asia. We also announced the Emerging Solutions Ecosystem Partner Program that we start partnering with Enstratius, Mirantis, Canonical, and Morphlabs that year. Last year, just like I showed in my previous slides, we launched this Dell SUSE Cloud solution for enterprise clients. And last year, luckily, we acquired Enstratius, and we renamed Multi-Cloud Manager. We started partnering with the Ink Tank to provide SAF unified storage systems for OpenStack deployment. So basically, this is what we had done up until last year. So in summary, we're not just here to be part of the OpenStack now, but we've been there since day one. Like I said, we also developed the Crowbar, and we also open sourced it. We have 2 board members, Rob Hirschfeld and J.B. George. They are the 2 board members of the OpenStack. So by providing these different sets of reference architectures, we really want to help customers save on their TCO. And we want to help them innovate aggressively with the same pace of OpenStack development. We want to help them scale their operations efficiently with the philosophy of operation as a software, which is so-called DevOps. I'm going to introduce you to Dell's cloud portfolio. As you look at the slides, the virtualization market segments, traditional virtualization market segments. There's advanced cloud, private cloud users, and also there's public cloud customers. This dotted line box, this is where we see as a market opportunity, or some of the people in the audience is really trying to realize. Let me just start off with the right-hand side, which is sophisticated cloud buyer. They're very active OpenStack user group members. They're open source savvy, DevOps savvy. Such as there are innovation labs, there are startups, there are telcos, hosters, cloud builders, or cloud service providers. Left-hand side, there are mainstream enterprise cloud buyers. They are the people who want house or mansion instead of all those variety of tool sets. They want to solve their business challenges, business problems with the proven technologies. They really want to focus on their return on investment and time and value. Even so, they're not going to adopt any solutions unless there's a firm risk mitigation strategies. In terms of workloads or application requirements, for traditional mainstream enterprise clouds, yes, mission critical or enterprise applications, which is normally written for the scale up architecture rather than scale out. If all of us really want cloud adoption is really, really faster than we would anticipate, which is now happening, is the mobile applications or web applications. These are the fundamentally different architecture from the enterprise applications. They're scale out. They are the applications who utilize the most best out of the cloud. So from Dell's portfolio perspective, we have Dell Active System Manager, which is ASM. We also have solutions in conjunction with the Microsoft as well as VMware. And as I talked earlier, we do have Dell OpenStack cloud solutions based upon our reference architectures. This new announcement is fitting right there. So Dell Red Hat Cloud and OpenStack. These are the enterprise class, and these are the solutions that lots of enterprise customers are waiting for long. I'm going to talk more about this Dell Red Hat OpenStack solutions. So basically, OpenStack is now open for business. We're going to officially launch this program at both Red Hat Summit as well as OpenStack Summit in May in Atlanta. Talking a little bit about these offerings, it's enterprise grade from enterprise experience. By providing support services from both companies, we actually help customers innovate without risks. The reference architectures we're going to emphasize and developing and building right now is not going to be a general purpose cloud, but more specifically designed for use cases. For example, a reference architecture for software design and storage, or reference architecture for dev testing, dev scale-out testing, or reference architecture for cloud scale applications. So we're going to certify this whole reference architecture, each components, by the both company. And each professionals, they are all certified by both the companies. This slide shows the components. So from bottom up, both the companies jointly provide code developments, support services from the both companies, professional services, certifications, and initially, the solutions architecture composed of Red Hat OSP v4, Havana, Rails 6.5, and Dell's resources, compute, storage, networking. I'm going to close out my presentation with a case study, which we actually helped a customer in the United States a few months ago, who are at University of Alabama at Birmingham. Some of you are already exposed to Ceph, but some are not. But unlike traditional enterprise storage, a Ceph is consolidated unified storage systems provide both object and block storage systems services. It's open and it provide unlimited scale, theoretically. The Ceph cluster can interact with OpenStack via Ceph Object Gateway, which is called Rados Gateway, or provide Rados block device through the Cinder plugins. The customer's challenge was there are many researchers in the community, and data management becomes so headache. While the whole community wants to utilize all those data for their research or projects. We met customers and I come up with the solutions together. Okay, we're going to choose OpenStack for compute. Okay, we're going to adopt with the tremendous support from our Crowbar development team. We're going to adopt Ceph storage systems to meet both business and technical requirements. Indeed, they realize 41 cents per gigabyte. And it's scalable up to 5 petabytes in the years to come. Very demanding workloads like HPC, and realizing HPC workloads on top of OpenStack Cloud or such a cloud is very, very demanding job. Not only this UAB case, but also I've directly engaged the case in Australia, which is Australia National University. They also adopted Ceph as a backend storage to provide both block and objects for service providers, this provides opportunities. Service providers, they want to enlarge their market segments, and this HPC, very high-profile workloads support services, it is something the service provider may be interested. As a whole, when you look at this whole diagram picture, on top there is cloud services layer, and obviously researchers, research communities, users, they use virtualized server storage computing cloud based upon OpenStack, Crowbar, whilst the operation team enjoys all the features from Crowbar, a Ceph. So the front-end side, it's a 10 gigabit Ethernet fabric, switching fabric, and the back-end side, that's InfiniBand. So this is the end of my slide. So for more information, please visit dell.com/OpenStack. And if you go out there, this booth, there's very fine Dell folks out there and who put extra efforts to realize this demo. So one of the examples is they realized Cinder plugins drivers with the Dell Ecologic storage systems. They also can show you how you operate with the Crowbar for your entire OpenStack from deployment and operation. And they can also address some of your questions in Japanese about Red Hat collaboration as well as SUSE collaboration, or even our OpenStack reference architecture, depending upon your business or technological challenges requirements. Thank you very much.
ピーター様、ありがとうございました。